let's do this practice problem. I made it up based on some other problems. So not completely original, but who's really original anyway, right? So it's fine. Let's go over the problem. A metal block floating in space has a mass of 2.1 kilogram. A piece of debris, there is debris in space, has a mass of 0.06 kilograms and an initial velocity of 180, 190, 0 meters per second. It hits the block and recoils with a different velocity, 165, 50, 0. What is the resulting velocity of the metal block after the collision? And what's the increase in thermal energy of the debris and block together? Okay, so I drew a picture right here. So here's my block. I'm calling that B, and then here's my debris. So my debris comes in and it hits, and then it reflects off, and that bounces, that recoils. And so we want to recalculate this. I know these two velocities. So I know the velocity of the debris initial is 180, 80, 190, 0 meters per second. I know the final, VD final, is equal to 165, 50. Oh, it's still going the same way. So it's like this. 50, 0. And they're not sticking together. Okay? So I don't really know what's going on, but they're not sticking together. Maybe it's a glancing collision. I don't know. It doesn't really matter. And then we want to find, we know the initial ball velocity is 0. I mean block. It's a block. Block, block, block. And then we want to find the final. B final. Question mark. We don't know. I do know the mass. Let's put it up here. The mass of the debris, D, is 0.06 kilograms. The mass of the block is 2.1 kilogram. Okay, so if it's in space, there's no forces on it. I can say my system is the block plus the debris. And there are no external forces on the system. So that means that if I write this, F net is equal to the change in momentum with respect to time, and that's the momentum of the system. The change in momentum of the system would be 0 because the net force is 0. So if this is my system, the net force is 0. And that means that if delta P is 0, 0 vector, then the initial total momentum is the final total momentum. So I can write that as mass of the debris times the velocity of the debris initial plus 0, because this is not moving at all, so I don't have to put that in there, is equal to mass of the debris, velocity of the debris final, which I know, plus mass of the block, velocity of the block final. I can subtract this from both sides, and I get, and divide by the mass, I get the velocity of the block final is the mass of the debris, velocity of the debris initial, that's subscript. I'm going to write a new piece of paper. I feel like I'm making a mess. So mass of the block, velocity of the block final is going to be equal to mass of the debris, velocity of the debris initial, minus mass of the debris, velocity of the debris final. And then I divide both sides by the mass of the block, and I get the velocity of the block final is equal to the mass of the debris, velocity of the debris initial, minus mass debris. I could factor that out. Debris final divided by the mass of the block. Okay. You can do this, right? This is just a vector subtraction here. That's not hard. And then dividing. I'm going to do it all in Python because I don't want to do it otherwise. And no one can stop me. Okay, so let's switch over here to Python. I've already got a Python empty blank page open up. Python is a great calculator. If you don't use Python as your calculator, it's really nice. So let's just enter everything we know. MD, the mass of the debris, 0.06. MB, the mass of the block, 2.1. VDI, I'm writing it like that, is the vector, I can't remember what, there it is, 180, 190, 0. So we have these vector classes built into WebVPython. This makes it so much easier to do these calculations. VD final is vector. Looking at my paper, 165, 50, 0. Now, I already calculated the final velocity of the block as an equation. All I have to do is type that equation in. Velocity block final is equal to parentheses mass of the debris times velocity of the debris initial minus mass of the debris times the velocity of the debris final. See? That's not hard. Divided by mass of the block. Now I can print that. Print. And I'm going to write it as this. I want it to look nice, right? Velocity of the block final is equal to VBF meters per second. And let's run that thing. Boom. There's your answer right there. That's the recoil speed of the block. We did half the problem. Okay, let's switch over to the second half of the problem, going back to the paper. The second thing says, what's the increase in thermal energy of the debris and the metal block together? So if I have, let's just draw our system again. It's moving here, right there, and then this is that's time, right? Afterwards, this is now moving that way, and that's moving that way. Let's, again, take my system. Take our system of the block plus debris. And if I think about it in terms of energy, I can say, well, what's the work is equal to the change in energy. But if that's my system and there's no external forces, then there's no external work, so the work is 0. And that means the work is going to be the change in energy, which is going to be the change in thermal energy plus the change in kinetic energy of the debris, that's a D, plus the change in kinetic energy of the block. So I just need to calculate these changes in energy, and I know they have to add up to 0, and that means I can find the change in internal energy, the thermal energy. So the change in thermal energy is going to be negative the change in kinetic energy of the debris plus the change in kinetic energy of the block, or negative K debris final plus, no, minus K debris initial minus K block final. There's no initial kinetic energy of the block. How do you calculate kinetic energy? Well, I know the momentums, but I know the velocities too. So kinetic energy of the debris initial is 1/2 mass of the debris, velocity of the debris initial squared, and that's a vector, so I need to find the magnitude of that vector and square it. And then I do the same thing for the block, and final, and then the block. And so those are vectors. You're going to have to find the magnitudes and square them. But I'm going to use Python, so it's going to make it a lot easier. Let's go back over to our Python. I mean, I didn't start Python just to abandon it. I'm going back over here. So let's calculate some stuff. So I'm going to say capital K, debris initial, is 1/2, 0.5, times the mass of the debris times the magnitude of VDI squared. So the magnitude is a built-in function in Python that returns the magnitude of the vector. I can print that if I want. Let's go and print it. Print KDI equals equals spacing KDI joules. And this is run just to make sure it's working, right? There you go. Okay, now let's do the final. KDF is 0.5 times MD times mag VDF squared. Should we print that? Fine. Print KDF equals KDF. I'm putting the units, see? I'm doing everything. Joules. So it decreasing kinetic energy. And then we'll do K block final. It's going to be 0.5 times mass of the block times mag velocity of the block final squared. And print that. K block final equals K block final joules. That's not very much. And it shows you this big difference between kinetic energy and momentum, right? They're totally not the same thing. Totally not. Okay, now I can just say, let's call it D. I'm going to write it like this because I get kind of confused with minus signs in my head. So I'm going to say dk debris is going to be equal to K debris final minus K debris initial. And then dk block is k block final minus 0. And so now I can say d thermal, dE thermal, is going to be negative dkd minus dkb. That looks bad, but whatever. Print d delta E thermal DET joules. If it's not positive, I'm going to be upset. Okay, whew. So the increase in thermal energy of the two things together. And so we can't calculate the change in temperature really, because we don't know how much energy, thermal energy, went to the debris, how much went to the block. It's more complicated than that. But we can calculate the total change and it's not just thermal energy, it could be deformation energy and stuff like that. But that's the total change in energy because of the loss of kinetic energy. It had to go somewhere. Okay, so that's that. Was that fun? If you do that on a calculator, you can do it on a calculator, right? It's just a lot more typing and stuff that I don't want to do. So I did it in Python. I'm not even going to save this code because I don't even care. But there you go. Hope that helps.